Greetings. A while back I got this AC Measure device from M5Stack, and I've been meaning to give it a test and see what it can do, which is what I've done, and now I want to do a little video on it. And it's an interesting device based on some interesting chips over there, which we will have a look at. Now, inside of this device is a little PCB. It looks like this. So it is actually a reasonably simple design, because the this little chip over here is actually the heart of the thing that actually senses the voltages and current and power and so on. So the power comes in, goes to a 1 milliohm resistor, which is what this thing is, can handle 10 amps. This over here is a 1 ohm resistor, but it's really used as a fuse, and it is isolated. You can see there's a little slot over here underneath. There are several more if you turn it over. There's an opto-isolator here, which actually the chip actually communicates via just a simple 4800 baud UART, and the signal is passed through this opto-isolator into this ST32 microcontroller. And this thing over here is actually a 20 milliamp DC to DC supply, which actually is specifically made to isolate from the input to the output. So it is completely isolated from the mains, which is a good design. This little guy over here is just a 3.3 volt linear voltage regulator, and there's a bunch of capacitors and resistors. These ones over here, we'll have a look at the circuit and stuff. They are used to cut down the input voltage to a level that this little chip can work with. Okay, so this is the circuit for the device, and this is the AC input and output connector over here. Connects to this little resistor network. This one over here is that 1 milliohm resistor special device there that it uses to measure the current and so on, and the little resistor divider here for the necessary input, so it can measure the RMS voltages and what have you. There's a TX output there for that chip that actually goes to the opto isolator, and it generates this RX signal. The RX signal in turn goes to this microcontroller, which is an STM32, and there is of course an output here, SCL, STA, 5 volt and ground, which is a Grove connector, which actually comes from here, SCL, SDA, and that's really all there is to it. There's really only 3 pins used on that microcontroller to connect to the external world and to actually communicate with that chip over here. The AC in is actually going to a 470k resistors over here, with a 1k resistor to ground, so that the input voltage to the chip here is actually reduced much lower. I think it's like 4 volts or something maximum or something. I can't remember. We'll look at the data sheet to remind us. Because the input voltage can go as high as 250 volts AC RMS, so it has to be cut back. The isolation is done via this opto isolator for that RX signal, but also this DC to DC voltage unit here is specially made to isolate there's 5 volts going in and 5 volts going out, basically, which is isolated from the mains voltages over here. There's also a little connector here which has pins underneath the actual growth connector, which is not connected to anything, which's got MCU, SW clock, MCU, SW IO, and a restart signal, and 3.3 volts and ground, which is the other pins on the MC32, STM32 rather, which makes me wonder, that is probably used for testing and programming the microcontroller maybe. Doesn't look like a JTAG connector, but then on the other hand, maybe the signals are compatible with that. It's something I have to investigate, because as we will see later, I don't think that this firmware in the STM32 is ideal. It does some weird stuff. The circuit itself is fairly standard. This particular part of the circuit here is exactly what the datasheet has in it, so there's been no innovation here. And the only thing that they have added is this isolated power supply and this opto isolator to isolate the high voltages from the low voltages. So communicating with this device is done via that microcontroller, and it actually has an I2C protocol, it says, and you can get the voltage, and this is the bytes or something that it outputs, the current, the wattage. There's also an apparent power, which I'm actually not picking up right now, which is like VA. There's the power factor, which shows you whether the load is inductive or capacitive or resistive. In any case, this is how it communicates. It has these different registers, register 0, 1, 2, and so on. Okay, so this other chip there is that isolated DC to DC converter. So it has the ability to output 3.3, 5 volts, 5.4 volts. There is a pin over there that they call trim, and if it's connected to one of the other pins over there, then it outputs 5 volts. And that's how, indeed, is how it is wired. So I don't think we need to look much into that. It's just a chip that you put 5 volts in and you get 5 volts out, and the 5 volts is isolated from the voltage that's coming in. Okay, so this is the HLW8032 datasheet, user manual. They seem to be available at different places, including DigiKey and Mouser, I think, and LCSC or whatever it's called. I think I've seen them for about 51 cents each or something. They're not very expensive. I don't know what the volume is though to get that price. So it can measure effective value of power, parent power, current, and voltage, output of electric energy, see pulse from PF, pin, measuring errors 0.2, 0.5%, UART communications for connecting to microcontrollers, a little block diagram over here. Eight-pin package, voltage in and ground, and it's got the RX, PF, TX pin. The TX pin is the one that's being used in our circuit. The input connections. This is the circuit. As you can see, it's entirely the same as what this unit is from the datasheet here. The 470k resistors, the 1k resistor, the 1k resistor there, the 1 milliohm. It's all exactly the same. AC/DC, that's that unit that is actually giving isolated 5 volts for it, and this one says 220 volts, but according to what M5Stack says, is 100 to 250 volts or something, but it can actually do less than that. I've got a little 20 volt transformer that's perfectly capable of measuring that as well. Interestingly, there are some people that are selling boards with this little chip on it. There's non-isolated ones and there's isolated ones, like there's one here. There's even a GitHub project here which seems to have some code in order to talk to this chip, which could be useful. I haven't looked at this, but this is the same circuit, you know, that what we saw. They're also bringing out that PF signal here through an opto-isolator. And what else is there? Then there is this something to do with DigiKey Maker IO. There's a whole little project here and a YouTube thing on it as well, which I have not looked at in any great detail, but I even have a PCB for it. I will be looking at that, and I might even I got the kilowatt hours there. I might even try to do something like that. They're using a Arduino Nano, which I wouldn't be using. I'd use something else. Here's the Nanos over here on the PCB, and anyway, there's some interesting stuff there that obviously some people have looked at already, but we are looking at the M5Stack version and seeing how it works. So I've already got it running, and as you can see right now, the it says resetting, because what it actually does is it's got no it's got voltage. I got a variac connected to the device. I can actually change the voltage. See, now it is like 46, 47. I'm increasing it slightly, let's say 50 volts. Because it's not drawing any current, it still says 0.05 amps, and you see though how the wattage is fluctuating like that. It is very inaccurate. Power factor is coming back with crazy values, and every 15 seconds, I think roughly, it actually shuts down. And but we'll have a look at it in a minute. I'll show you what I've done. I put a little relay on it that actually powers it down and powers it back up, and then it starts working again. So that is an anomaly on this device, and I would blame the firmware for that, I think, because what it should be doing in this case is just saying, oh, I can't measure this, there is no current flowing, and it should just come back with, you know, a value of 0 or -1 or something to signal to you that, you know, something isn't right, or some sort of status saying no reading. So the M5 AC Measure Unit has a GitHub page, as you can see, and there is a example. Okay, what does it say? Source code here. This is where I got the AC Measure Unit CPP and H file from. I just copied them into the same folder where I was running my demo from. And there is some example code here, which is just called demo. And this is where I got the code from to actually display the values, basically. But they have, as I said, they have a M5 canvas display module, and which they are using, and I don't have that one. I have the TTGo one, so I had to change the display code, and eventually I added some other code to it in order to make it a little bit more reliable. So this is where that came from, just for the record. GitHub M5.AC Measure Unit, M5Stack. So I therefore modified the code here in order to use this TFT ESPI for that particular board. But and this code over here, AC Unit Measure, came from that GitHub page. It has the address of the default address of this unit is 42 hex, and codes for the registers and so on to read them, and so on. And this is what we're using, and that code is entirely the same as I got from the demo unit. The only the thing that I changed is to use the display in the TTGo board, but because it was behaving in strange ways, I put some code in here to trap some of that and see if I could make it more reliable. Which so I created a little thing, sensor power, that I can turn it on and off, which is connected to pin 27. On the output open drain pin 27 high. This is just test code. I created some functions there to show data on the display, show lines of data, and some other ones that actually shows at a location on the line. So it's got an X offset and an X offset, and then go to the next line. Just some conveniences for showing data on the display. Show results, inputs the voltage AC, the amps and the watts and the power factor, and it then goes and displays those. Now, if it does a few little checks over here, which is something I added. If the voltage is invalid, then we will display like dashes. So if it's blank, then I am telling it to actually remember the last values, and if the last values are valid, I will just keep those on the display, so it doesn't change randomly. I also calculate the power value according to what's from the voltage and the current, and if it is within different, if it is 10% different than what the calculated value is, then I'm actually displaying the calculated value, but I'm putting a little star after the W on the screen to show that I'm showing the calculated value. As I said, I'm just experimenting here. Displays the values. If the sensor says it is ready, and I know for a fact that that is not working properly very well. It says it's ready sometimes, but there is no current or volt or wattage present. As I said, I think that the firmware needs updating. It says firmware value comes back with 1. And I don't know how many of these things they sold. The actual page on AliExpress says they've only sold 14. So maybe they're not selling very many, and therefore they've lost interest in it, and there's never going to be an update for it. I don't know. I put a question on both on the GitHub page and on their web page for get information about this. You know, why is it shut down and all that kind of stuff, and I've had no response whatsoever. So it is not very good at responding. This code actually pretty much came from their demo code. Um, so that is that. And it is actually, this is what it is outputting to the serial, which is different from what I'm displaying on the little screen. And this was some other stuff that I'm not using, and that was from that demo stuff. All right, so let's have a look what we've got. So what I have is in the top left corner there, I've actually plugged in a one of those power meters that I have that currently set the voltage. It's a bit of a pain, that thing. I wish it had could display, you know, voltage and current, and like I'm doing on the little TTGo thing there. At the bottom left over there, you see what it is currently reporting from that TTGo thing. On the microcontroller, the source code that you just saw is running on there. Notice that when it has a little star next to the W, it means that it came back with a crazy sort of power value, and I'm displaying the calculated values. So if it was 48 volts and it was indeed 50 milliamps, and that is what it was. But in actual fact, that isn't mentioned because this is the plug. There's nothing plugged into it right now, so it can't be drawing much voltage other than some losses through some of the components on there. This is a current meter, so we're going to put it on 2 amps, and I'm going to plug in. I have here's a plug. Let me get that. Okay, I have a heating element sitting below my desk, 0.59 amps, and the device now is coming back with 0.62 amps, 29.8 watts. Let me push this function button here. 0.6 amps, this one says. 29 watts, so it's not, you know, terrible. I don't even know how accurate that this power meter here is. I have no idea, but it's in the ballpark. I think that that's probably good enough. If I increase the voltage, and notice that it's, you see this little red light here that's on, that means it is actively working. If I set it to like 0 volts, it'll do that thing where it actually shuts down after about 15 seconds or so. But there's no voltage there, so the big power meter is shut down as well. Yeah, there it went, click, click. So what I've done is I've got pin 27 on this thing connected to this little relay here, and it's got a little diode across it, so a reverse voltage, and it actually shuts the power off on this plug. I've got the power for this thing is coming through the USB port, but the power for this is actually coming from my desk power supply. It's drawing 57, 60 amps, point 57 to 60 milliamps, and so I can actually shut the power off to it and shut it back on, then it comes back on. 32 volts, 16.3 watts, 0.4, 400 milliamps. It's in, you know, it's in the ballpark. It's so I'm thinking that if you have a need for measuring, you know, like a voltage on a device or something. And if the power goes off or something like that, or whatever, or the current goes crazy, then you can take an action, turn something off or whatever, or send a message or whatever. But and it works okay for that. So if I turn it right up, 140 volts AC, and it is 264 watts. It can handle up to 10 amps apparently, and the current is 1.86 amps. And 1.77. Now these guys here, this is actually picking up the magnetic field of that, and they are not totally accurate because of the pickup either. It can vary. If I move the wires around, I think sometimes you see a slight difference. But in any case, it's in the ballpark. And 255 watts according to the other power meter, 263 here, 1.86 amps, 1.77 amps. What does this thing say? 141.9 volts, 1.79 amps, which is close to what that the multimeter says. 2.55 watts. So I think it's a little bit optimistic on the current and the power, and I believe there is an ability somewhere to adjust that. In any case, that's what it does. Power factor says 1, which will be correct because it's just a resistive device that I'm driving from it, not in capacitive or inductance. So I'm going to have a look at it. I'm kind of curious if I can hook my own microcontroller up with that port that's underneath there, see if I can get it to communicate with it or something. I might even be able to update the firmware. I don't know. I'm gonna, when I have some time, I'm gonna play with it and see what I can do. But as I said, if you have a need to monitor like your mains voltage, 120, 240 volts wherever you are in the world, and you want to know if the voltage goes above or below a certain value, I think this thing could be used, and it seems to be reliable enough to do that. But at low current, it'll shut down, and then you have to actually remove the power and power it back up, like I'm doing with that little relay over here, to get it back up going again, which is annoying. Anyway, in any case, I'll see you guys later, and don't forget to subscribe and bells and whistles and whatever it is to get me a little higher rating on YouTube. Anyway, I'll see you guys later. Bye bye.